So in the previous part, we learned how to create the constructor. So in this case, we have the constructor to create a new point by using only the parameter. There are some common constructor bugs. We call it bugs. You know what is bugs? Sometimes people will call it bugs as an error. Because bugs is very small and sometimes we cannot see it. Then people say when you have errors, you will have bugs in your code. So when you are having a bug, there can be something like this kind of error. Accidentally writing a written type such as point. So public point. So this is error. Okay, because constructor means you will construct a new object. You cannot use point. You cannot use int. You cannot use double here. So it is only the class name, which is point. So if you check this one, if I go to the point, and then if I create point, what happened? No errors. Okay, but when you run this, there will be errors here because they cannot recognize what is the point 5,2. So you cannot have point here. It is only the public and point to indicate this is the constructor. Okay. And then the other kind of this is not a constructor at all, but a method. Okay? So if you put point or integer or double or something with the data type, then it will be a method, not a constructor. We are going to build constructor. Okay? So please don't be wrong with this one. And the second errors, it is about the storing into local variables instead of fields. You know what is meaning by fields? Yeah, we know that we have the x and y. So those are fields. And then I have the p1, and I want to say, let's say p1 is equal to 3,8, like this one. Then this is the field. This is the fields. And if it is the fields, it should be in the global variable. Okay. If it is in the global variables, you already learned about local variables. Here, if you define with int x, now it becomes local variables. And it is wrong. Because I want to update the fields. I want to update the global variables. And the global variables should not be defined here. It should be defined in the global variable. Okay. The global variable is outside the constructor. I can say the global variables should be defined in the early parts. So the first part after the class name, you will define the global variables or the fields. If you define like this one, this declares local variables with the same name as the fields rather than storing values into the fields. And the fields will remain 0. So let's see. Okay. If you define like this one, then the fields will remain 0. Now let's see if I want to change this. Okay, this is the line number 8. I change to integer x. And then I change to integer y. Okay, if I save this one, no errors. No errors at all here. But now you can see the color. What is the color now? It becomes gray. If it is blue, then it is the same with the global variable. If it becomes gray, then it is a local variable. Now, I want to run this point main tree. What happened? When you run this, now everything will be 0. Okay? Maybe you will ask, Professor, why it is 0? I already defined 5 and 2, 4 and 3. Yes, because you define this as the local variable. So the local variable will not update the global variable. Okay, be careful with this one. So you need to delete this one in order to fit the x into this global variable. So global variable means whenever you call the x, it will be in this method. 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 So all methods will have the same value of x. And all methods will have the same value of y. Okay. A class can have multiple constructors. Multiple means many constructors. Each one must accept a unique set of parameters. Okay. So this is the same with method. When you describe a method, okay, you need to have a unique set of parameters. Now, there is a problem here. Write a constructor for point objects that accepts no parameters and initialize the point to the origin. It means like this. If I define point P1 equals to new point 2, 5, it means I will define this as a new object P1 and the value of x will be 2 and the value of y will be 5. But if I want to have a new object P2 and let the x equal to 0 and the y equals to 0. So I can just define with P, the point P2 equals to new point 0, 0. This is also okay. But how if I want to just have this one? So if there is no parameter, okay, because this is accept no parameters, there is no parameter and it initializes the point to the origin, which is 0, 0. So I want to use this one and it will give you x0 and y0. Then this is the solution. You can create a new constructor without parameter and let's set the x equals to 0 and y equals to 0. So I can have a new public point, and then just with the parenthesis, and x equals to 0 and y equals to 0. Okay. By using this one, what happened with the point main? If you don't have this one, there is an error in the point main.java. Okay. You can see there is an error here. But if I put the constructor with x equals to 0 and y equals to 0, now the error will disappear. So the error now disappear. It is because I create a new constructor and I would like to initialize x equal to 0 and y equals to 0. If you check on the point main here, we create a new point p1 with a point without any parameter. And if it is without the parameters, I will expect that x equals to 0 and y equals to 0. Okay. By default, Java does not know how to print objects. Let's say if I have p equals to new point 10,7. And then if I print p, then it will be blah, 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 something like this. So let's say I want to system.out.println p2 plus p2. Okay, so I want to print p2. In the upper part, you want to print p2, and then I want to check the value, which is x. So I want to print p2.x, p2.y. Now, if I run this, you will see something. Yeah, you cannot understand. What does it mean? Okay. This is what we call as the computer memory address. We can print a better string like what you saw before. Yeah, we can print p and then p.x, p.y. I want to print the element x, I want to print the element y. This is possible. But I would like to print something like this one. If I want to print p, and then if I just call p, I want to show the all values, which is 10,7, without doing like this one. How can we do like this one? Here we need to define what we call as toString method. Tells Java how to convert an object into a string. And then we can call the objects when it is concatenated to string. Let's say this one. P1 is the point 7,2, and then I want to print P1. If you prefer, you can write toString explicitly. So let's say we want to have toString. If you run this, you still have the same. Okay, you will still have the same result. But what we expect to do with this toString, it is the already built-in method in Java. Even though you do not make this method, Java has it. Every class has a toString. So every class, when you create a class, you can have toString. When you have another class, you will have also the toString method, even it is not in your code. So the default name is toString, and it is in the class name, and it has the like hexadecimal based on base 16. In order to make the string, so we can use the toString and we can code it. So I can define public string toString. It means I will make the result of this toString method as a string data type. So the code, it returns a suitable string. The method name, return, and the parameters must match exactly. So let's see the example. I want to print X and Y. So I want to return back. If I call toString, it will return a string and it will show the parenthesis plus the value of X plus comma plus Y plus the closing parenthesis. So if you go to this in the point 4, oh, not yet. So in the point, okay, in this point, I would like to add one more method. The method will be public string toString without any parameter, and I want to return the parenthesis plus X plus the comma and plus the value of Y plus the closing parenthesis. Now I can run again the point main tree. Now I'm defining. I have defined the toString. So if I run this, now it becomes 6,7. How can I know that this is 6,7? Because here is the toString method. Now this is the outline of the point Java class. There are two additional constructor and there is one additional toString method. Okay. For a complete one, yeah, I give you another Java class which is point main 4. Okay. You can check on the point main 4. In the point main 4, I create two objects, which is 7,2, and then I create another object which is 4,3, and then I want to print P1 and P2. What is P1 and P2? Yeah, P1 is a point with 7 and 2 for the value of x and y respectively. And then P2 has a value 4, 3. Now I would like to make a distance from the origins. Then I can call the P1 dot distance from origin. So it will show the distance. Oh, this is not P1, this is not P2. Okay. So P2 distance from origin. Then I will call the object P2 distance from origin. I would like to translate P1. So P1 will be translated by 11,6 and P2 will be translated by 1,7. So I can print again the new P1 and the new P2. Let's say I want to check the distance between P1 and P2. So I can put the P1 dot distance. It means I want to check the distance to another point. What is another point? The other point is P2. If you run this one, then I know that the P1 is 7,2 and P2 is 4,3. P1 is 7,2, P2 is 4,3. And then I have the distance from my origin is 7,2 something something. And then P2 distance from origin is 5,0. And then the new P1, this is the new P1 after we translate 11,6. So 7 plus 11, it is 18. 2 plus 6, it is 8. And then 4 plus 1, it is 5. And then 3 plus 7, it is 10. And I want to check the distance between P1 and P2. So this is the point. It means I will do the 18 minus 5, which is x2 minus x1, power of 2, plus the 8 minus 10, power of 2. And then we will do the square root. So it means 13 power of 2 plus 2 power of 2. Here, minus 2 power of 2, it will be positive. And 13 power of 2 plus, and then we will do the square root. So the result will be somehow like this value. In object-oriented, there is a concept about encapsulation. The encapsulation means hiding the implementation details of an object from its client. So we do not want to show all the implementation details. We just want to show something. We just want to show partly of our code. So encapsulation provides abstraction. It separates the external view behavior from the internal view. What is the state? And the encapsulation, it protects the integrity of an object's data. Now, I would like to teach you a new part of this one. We call it private field. As I mentioned to you, we have like table like this one, and then we have the x and y, and we have the P1, we have the field x and y. In most of the examples, I declare this one as public. What is the meaning by public? It means that everyone can see the data. Everyone can access the data. But I would like to change it. I would like to change so no code outside the class can access or change it. So I do not want other people access the data. So if they want to access the data, they need maybe to give some kind of password, or they need to give their credential, user ID, so they can access and they can modify it. For this purpose, we can make it as a private. And this idea is the same with what you already did, but you can just put as private, and then explain what is the data type and what is the identifier name. Private string name. So this is the data type and this is the variable name. So if I do not want to share the data, yeah, you can make all the fields as private. Client code sees an error when accessing private fields. So if you see this one, at this state, you will see that the point main 3 and point main 4, they are okay, no errors. Okay? And they access the data. How do they access the data? Is by finding the x and y. And maybe this one, p1.x, p1.y. Now I would like to change this data is still public, even though you don't declare public like this one, but it is still a public. I would like to change this into private. And if you see this one, when you change into private, the figure here now changed to red. That means the integer x is not public, or it is not available for other code to access this variable. And if I save this one, and you will see that the point main and point main 3 now has an error, because the variable is private, you cannot access it. And if you want to check the errors, where is the errors? Here is the errors. What is the error message? The field point.x is not visible. So it is in private. If I want to check, you can see here, now I have the point main 5. It is still an error. Now if I want to make it as the private integer y and x, okay, now both of them are in private, and you will see that this 2 now is in private. The point main and point 3, now it is error. So we need to provide method. We call it, this is get set field value. So whenever if you have the private state, someone who wants to access the data, someone who wants to modify the data, they need to access the method, not the field. So it means someone who wants to modify the data, they need to access the method, not the variable. Oops, I can see it. someone who wants to modify the data, they need to access the method, not the variable. Then I would like to make a new method which is public integer getX. I will make a new method here, public integer, which is a written method, getX, and I will return x. So if someone wants to get the value of x, they need to access this method. They cannot directly access the variable. Okay, so the variable will be in private, and this method will be in public. Actually, you can also do other things with the method as well. You can change this to private. Okay. So if you can understand the public and private, then you will know what is the private method, what is the public method. Now let's just use public for all the methods. And if you want to declare some variables in private, you can use this way to access the data. This is a read-only access. If you want to mutate or if you want to change the value, then I can have a new method which is public void set x. So the public void set x means I want to set the value of x with a new value which is in the parameter, which is a new x. So the new x will be given to the field x. So I can make a new method again here. Public void set x. And then I need to declare here integer new x. And in this case, the x will be equal to the new x. Because I would like to update, I would like to modify the current x with the new one. Okay. So if you want to have a new code, okay, so if you have the new code, you will have like p1.getx and p1.getY. We have two fields. Okay, we have x and y. So we need to update this one. Not only get x and not only set x, but we need to have also public integer get y. It will return y, and then I need to have also public void set y, which is having a new parameter, one parameter, and the y will be the new y. Okay, so after you set all those things, you can see that the point main 5 now there is no error. Now you can see this is one of a class with one, two. There are two constructors. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 methods. In your team project, I guess your class will be similar like this one. You will have a lot of methods. You will have a lot of fields. It depends on your problem. Okay. So This is the final one. Oh, this is the version 4. Okay. This is the point class, the complete one. I have the private integer x, private integer y, and then I have the constructor with 2 parameters. In my point Java class, I have another point with no parameters. We can calculate the distance from origin with this, and then we have get x, get y, and we have set location, we have translate. So if we have take this one, we can build the class diagram. Because this is the class diagram. Something is different in this class diagram. What is the difference? X become minus. Y become minus. Why? In by the definition, class means public. So whenever you set a public field, public method, or public constructor, then you will put plus. But if you put as a private, then you will put negative or minus. So it is the private symbol. Because I want to declare the x and y as a private, here is private, private. So I put this as negative, and I put this also as a negative. Okay. And in the point main 5, you will see something like this code. We have P1 with 5,2, P2 with 4,3, and then after I define these 2 points, I would like to get the value. So get the value, now I'm using the function get x. I'm not accessing directly the variable. And then I have the get y. I want to get x, get y, and then I translate the point. After I translate the point, I would like to get the new x, and I want to get the new y. You can run the point main 5. So here is the result. We have 5,2, which is the original point, 4,3, which is the original point of P2, and then I want to print. So I want to print the value of x in the P1, so I use the get x. What about if I want to check the x? Okay, it is not available with x. It will show you an error. What is the error? The field point x is not visible because we already create a private x. Okay. So what is the benefit of this encapsulation? It provides abstraction between objects and its client, and then it protects the object from unwanted access by client. For example, if you want to make a program about bank, of course, you will not permit the client to change the account balance. So if you have some money in the bank and then you can get the account balance public, but it is not available because you need to forbid the client to change the account balance. You can just see, you cannot modify. Allows you to change the class implementation. Yeah. So for example, a point, you want to change the coordinate to another polar coordinates. So maybe we have this x comma y. I can change into the radius and angle. So you can make a new method. You don't need to worry about the private because you can just create a method in your class. And it allows you to constrain object states or invariants. For example, yeah, you can allow only the points which is non-negative. Non-negative means positive. So if, for example, I do not want, if I know there is a coordinate like this one, I want to have the value only in the positive. So I want to have only the value here. I do not want to have the value here. I do not want to have the value here. I do not want to have the value here. So you can use this kind of encapsulation to apply with this kind of things. Okay. At the end of this PowerPoint, we have a kind of exercise. I call it this is exercise. Even though I give you one code, you can see the code in your Eclipse. But I want to share how you can design your team project later. I hope that until next week, when you are presenting your team project, you have your idea at least about the class. I'm not sure now what is your team project title, but if you can make the class, it will be good. Let's say I have this student class, and I want to have two fields. I have two attributes, which is name and GPA. So I define name as a string and GPA as a double. And then I put negative because I know those are private. So I do not want to make it public. I just want to make it as private. And I have one constructor. Okay. We call this is constructor. And then we have 1, 2, 3, 4. We have 4 methods. Get name, and then it will return string. Get GPA, it will return double. And then set name, it is a void, and set GPA, it is a void. Okay. Now, if I want to include 3 students, so the number of students are 3. I want to include one by one. So student 1 name is Bob, student 1 GPA is 2.1. Student 2 name is Chloe, student 2 GPA is 3. Student 3 name is David, and then student 3 GPA is 3.10. The student with the best GPA is David. The average GPA is 2.86. How do I know David? Yeah, among the GPA 2.5, 3.0, and 3.1, the highest is David. And what is the average? Yeah, 2.5 plus 3.0 plus 3.1 divided by 3. So how can you make this code? Okay, so I already defined the code. You can go to the student.java. We have private string name, we have private double GPA. So you can check this line, okay, this outline. This outline will be the same with the class diagram that you see on your PowerPoint. It will be the same with this one. And this one, okay, it seems the time to finish because I know you have other class. I will continue on Thursday to explain the details of this program.